Hi, everyone, and welcome to Unity Central at Siggraph. My name is Sarah, and I'm going to be presenting on developing for XR with Unity. Before I begin, I'm just curious, raise your hand if you've built any type of XR application in Unity before. Okay, so if a good amount, that's good. Has anyone here built something else that's not XR, like a mobile game or a PC game? Okay, cool. And is anyone here completely new to Unity? Yay, welcome. So in this presentation, I'm going to give a quick introduction to Unity for XR and talk about the platforms we support and go over all the different ways that you can integrate with these platforms using Unity. And then I'm going to do a couple of demos in the Unity editor. I'm going to show you how you can use native APIs to connect to these touch controllers or any VR controllers. And I'm going to show you guys how to use Apple's ARKit to get AR on an iPad or an iPhone, which is a lot of fun. And I'm also going to talk about some tools for artists that are useful for XR development as well, and show you one of those tools here live on stage. And again, I'm Sarah. I am the XR Evangelist at Unity, so I am focused in all things VR, AR, MR as it relates to Unity development. And if you want to connect with me on Unity Connect, my profile is Sarah. I guess there aren't many Sarahs on there yet, so I got it first. And if you'd like to connect with me on Twitter, my handle is @Sara Stumbo, and I tweet a lot about VR and AR dev in Unity and all of our events, and probably will follow you back if you do the same. So for those of you that are completely new to Unity, I want to go over a little bit of like what Unity is before I just dive into the editor and start showing you things. So it's a content creation engine, and we have a wide variety of creation tools for artists and designers, programmers, team collaboration, etc. And it's also a powerful engine. We're here at Siggraph because we are a big believer in rendering really high quality graphics, and that's something that Unity does as well. And we support over 25 platforms. I'm not going to be covering all of these platforms today. I'm just going to talk about the XR platforms. But you can basically build an application once and deploy it to any platform you want. So even if you already have an existing game that may be for mobile or another platform, you could probably get that with a little bit of reconfiguration deployed to another platform. It's also really easy when you're developing for VR. Like if you're developing a game for Oculus, you also want it to run on the Vive. Works right out of the box. We also offer some live ops and analytic type services for developers to help you succeed, make money, see what your players are doing, and get multiplayer functionality in there. And we also want you all to make money with your apps that you make in Unity, so we have a bunch of monetization services. And all of that is undermined by our fabulous ecosystem of developers and our asset store. If you're just getting started in Unity, I would definitely recommend checking out the assets store. Tons of amazing models, materials, scripts, and like even like full games that have the source code on them are downloadable from the assets store. When I was first learning Unity, I downloaded the VR samples pack, which is made by Unity, and that's like how I learned Unity VR, and I got it for free on the asset store, so that's pretty cool. And we are here to talk about VR. One fun fact about Unity for VR is that about 70% of VR apps are made with Unity. These are a few of my favorite games. If you haven't played them yet, I highly encourage you to check them out. Another big one is Job Simulator, probably one of the top VR games on Steam. That was made by Alchemy Labs and made in Unity. We also have a lot of AR and mixed reality applications being made in Unity. Pretty sure everyone remembers Pokemon Go and how it like took over the world last summer. I remember like I live in Seattle, and I was running around Green Lake and like so confused why people were just like on their phones like in the middle of my running path. I'm like, can you get out of the way? But there were people outside, so that was good. And that was made in Unity, which is really cool. And people are also starting to leverage Unity for film and entertainment, especially for XR. A couple of my favorite VR experiences are actually more cinematic. I got to go to Sundance this year to try some of them. And actually, Life of Us, 0 Days, and Asteroids are all VR experiences. And those were shown at major film festivals like Sundance and Tribeca, and they were made using some of Unity's newest tools. Like I mentioned before, we have, I think, almost 30 platforms that we partner with. These are specifically the ones that we partner with for XR. So we have Microsoft with the Windows holographic, Samsung Gear, of course, Oculus and Facebook there. Vuforia, which I'll talk about a little bit later, is an augmented reality software kit. Sony PlayStation VR, and then we have Google as well. So as far as VR hardware goes, you can pretty much connect any VR headset into Unity. These are the ones, if you recognize these are the ones that we support natively. So we have Samsung Gear, Oculus 5, which uses the OpenVR, and then Oculus Rift, PlayStation VR, Google Daydream, and Google Cardboard. And one thing I like to point out is that there's a ton of native VR support in Unity already, and that's what I'm going to show you a little bit of. I know I speak to a lot of developers, and the first thing that they do when they want to start their VR project is they download all these extra toolkits and packages, which is great because there's a lot of useful prefabs and scripts in those toolkits, but they can also like really clunk up your project, and you don't know like if you have a stable version for that VR device. So when you're just using the Unity native APIs, you have that single API interface that you can deploy to all the different VR devices, which is a lot more convenient. And VR node is our reference to all of the different types of objects that you can track natively in Unity. So we have obviously head, that's going to be my HMD here, left hand, in this case, left and right controllers. We can also track a game controller. Hardware tracker refers to, like the HTC Vive has the little trackers that you can put on different objects to track those. And then if you're using your own like custom HMD that doesn't have a built-in SDK in Unity, you can configure the left, right eye, and center eye on your own. So I'm going to jump into a quick demo and show you how you would get started setting up like a player rig for your headset and controllers in Unity. All right. All right. Here we go. So I have my scene view here. And you can see I have this player rig game object here. And don't worry about these scripts in the corner. These are just kind of developer tools right here. I'm going to zoom in a little bit. All right, so I have my player rig, and underneath my player rig, I have a right hand. And let's see where that is. Oop, can't see because I'm zooming in. There we go. Right now, it's just going to be a sphere. For the purpose of this demo, that's fine. Then we have a left hand, also a sphere. Then we have an HMD. I think I'm going to zoom back out. There we go. HMD, and then we have a player body. So in this game that I'm showing you a part of, you have these different drones shooting at you and attacking you, and I wanted to include the player body in there so that the target would be targeting your player body. If one of the drones shoots a bullet and it hits your body, then you lose a life. So the player body might not always be essential, but you most likely want for sure, you're going to want a head in VR, and if you're doing interactive desktop VR, you probably want to have hands as well. So I'm going to go ahead and hit play here, and you can see that I have my HMD tracking automatically in Unity. And I just did that by going to my build settings and player settings. And then under other settings, I'll just have to check this little box here that says virtual reality supported. So it's pretty magical how easy it is to just start testing with a headset right away in Unity. You literally have to check a box. If you're using Oculus, you'll want to add in this Oculus SDK. And if you're using HTC Vive, it'll be OpenVR. All right, so I have VR set up. That's simple. And now I want to get my right and left hands tracked. So what I'm going to need to do is I'm going to need to write a C# script to tell Unity what it is tracking. And I've already done that, so let's take a look at the script here. We'll zoom a little bit here. All right, so we are using Unity Engine VR, and I just named my script VR Object Tracking. I mentioned in my last slide, we have a VR node reference, and so I'm just making that a public variable. So once I'm back in the editor, I can choose what type of VR node it is. So let's go do that right now. Oh, I have so many editor windows open. It's this one. All right. So I'm going to go ahead and add that script to my right hand just by dragging it over there. And we can see I have that node. Zoom in over there. I have that node publicly available. So I have all of my options here on what I want to be tracked, and I definitely want to be tracking the right hand because that's what I'm attaching it to. So I'm just going to select right hand here. All right. Pretty straightforward, and let's take a look at what the rest of the script is doing. So once we start up, if VR settings aren't enabled, we're just going to destroy the script. Pretty straightforward. I guess the most complicated part of this script are these 2 lines of code here, but they're very straightforward. We are just applying the transform of the right-hand VR node to parent the transform of the object, which is our right hand. So that's these 2 lines of code here. And it's really nice because you can get tracking with just 2 lines of code. So let's see that in action. I have my right hand here. I'm going to do the same for my left hand and left hand. Okay, now I might have to put this thing on. All right, there they go, already connected. And of course, I would want to replace them with something else. In this game, I will be replacing my hands with laser swords. And this demo is actually part of a full-scale VR workshop that I teach all over the country. So keep your eye out for Unity coming to your city, and you could learn how to make this whole game. All right. There we go. So we know how to track VR objects. So that's the most basic, I would say, way to just get started developing for VR right away in Unity. Of course, you will want to explore inputs as well. You can map the inputs of these devices to the Unity input system and pick up objects using colliders, just as you would with regular Unity development. I want to talk a little bit about AR hardware because I think it's a topic that kind of gets overlooked right now I guess it's not the year of VR, that was last year, so maybe it's not getting overlooked. But we do have a lot of platforms that are AR that work natively in Unity as well. For example, the Microsoft HoloLens, which I wanted to bring, but I couldn't fit it in my backpack with my Oculus and my computer. So I will be showing you an iPad demo instead, and the Google Tango, and pretty much any phone or device that you can add an object to. So Windows Holographic isn't just limited to the HoloLens now. They also have a mixed reality headset that uses outside-in tracking, and that will be natively supported, I believe, in 2017.2, which is getting released later this year. So some of the advantages of Windows holographic, we have simultaneous locomotion and mobilization, 3D object rendering and occlusion, really good spatial memory and understanding, gesture and voice recognition, and editor emulation. And all of this functionality is built into Unity. So you can call the APIs to recognize your gestures, which on the HoloLens is just this click, or do voice recognition, map your area, all of that natively in Unity. We also support Google Tango, and that integrated support will be coming in 2017.2. The Euphoria is an AR toolkit that's you can build on top of Tango, HoloLens, or Android or iOS, and that you can use that right now if you download their SDK. But the integrated support will be in Unity in the next release, 2017.2, and that's based on image targets. So as you can see in this photo here, our image targets are those chips and stones, and then we're rendering an object onto that image target. So if you're making an AR game or an AR experience, and you know exactly where you want your object to land in the room, you just put it doesn't have to be stones or chips, by the way. You can make your own image targets. You can place them anywhere in the room, and then your AR will just pop up right on there. Recently was announced the ARKit from Apple, and that also uses SLAM technology and markerless world-based tracking, and it's really easy to get started. And I'm going to show you all how to do that right now. All right, let's go to one of my other Unity windows. This one looks good. All right, so what I have here is I've simply downloaded the Unity AR Toolkit. Unity AR Toolkit? Yes. Oh, Unity ARKit plugin. Sorry. It's hard to keep track of all of the names of the SDKs. And this was made by Apple, and it comes with all the functionality that you need to build ARKit applications right away in Unity. So I have this sample scene here that it comes with, and really I'm not doing much. I'm just taking this sample scene and building on top of it. This sample scene here, the Unity ARKit scene, is like the first one that I opened with the project, and I realized that it kind of had all of the functionality of ARKit. So here we have just a random cube, and that's actually this cube here. And this just kind of helps you to understand your space in AR, this checkerboard cube, when you're developing and testing out your applications. And then we have some special functionality on the camera here, Unity AR video, and some other scripts that are just already built into the camera prefab when you get the application. And we have here this hit cube. So every time I tap my screen, this hit cube will pop up. And in this script here, which is also included as a part of the ARKit, that script just tells the application to render that game object when it's hit, but under certain conditions, because we don't just want to render our objects like floating in space. We want them to be interacting with the world around us. So what the ARKit is doing is it's actually looking for anchor points in your environment and planes that it can map objects to. And that's here what this generate planes object is doing, and this is for debugging, and we'll see it when I run the demo in a second. It's always going to be looking for planes, but having this script on here actually outlines the planes in blue, which we'll see in a second. And then point cloud particle is another debugging tool that'll actually kind of physically show you with a particle effect what ARKit is seeing in terms of point clouds. So there's just a couple changes that I want to make to my HitCube script here. I think I already have it open. All right, yeah, so one thing that you kind of have to work around is when you're in the iPad, you don't know if your object is always going to be facing the camera or not. So there's just a couple lines of code that you can add in to really easily make that happen. So I'm just going to do that right now. So I just want to make sure that my transform of this object is always looking at the camera. Transform position. There we go. And then I want to make sure those angles match up as well. Live coding. All right. Angular angle. Whoop. Y. There we go. And Z. All right. So now I know that anywhere I hit. Sorry for my sloppy coding there. Oh, whoops. That's supposed to be a 0. There we go. So anywhere I hit, we know now it'll be facing the camera. And then there's a couple other things in this update function here that I might want to change based on some preferences. So here it'll tell me what types of planes it can actually hit. So down here, I can actually just comment these out if I don't want it to hit any point in my scene. You have the option to map your objects just to planes, or you can map them to any anchor point that the application finds. So the really fun thing about this sample scene here is you can basically, there we go, you can basically replace this hit cube with any object that you like. So I've seen all sorts of things on Twitter lately, like people putting zombies in their living room and dinosaurs at barbecues and all sorts of stuff. And if we can have the lights, I will show you an example of how it works. So I've already built it to my iPad. It's important to note that in order to build for iOS, you need to be on a Mac. So I was just showing you this here, but I actually built it using my Mac and Xcode. All right, let's see here. 7. There we go. That's my iPad. And here is my ARKit build. All right, so we can see there's my random cube floating in space there. And see all of these yellow particles? This is actually showing me what type of point cloud we're generating. And now I see a plane right there, so I'm just going to tap on it. And now I have a little corgi friend. Just chilling. And I can move him around to different planes. Or I can just kind of make him floating in the air, which isn't as cool, but it's kind of funny. I think I want him on my laptop there. And of course, he stays where he's supposed to be. I think he's breathing too, which is good. All right. So really simple to just get started building AR. All I did was add 2 lines of code, and I didn't even really have to do that. I just did it so that the demo would look nicer. And you can download the ARKit plugin for free and start building these AR applications right now in Unity, like right away. That took literally 5 minutes, so pretty cool. Let's see. All right. So that's all I'm going to show from the ARKit, but there are a ton of other example scenes in this plugin that you can take a look at and explore. And like I said, I've already seen some people doing some pretty cool stuff with the ARKit. I've showed you guys a lot of tools for developers and programmers, kind of dived into the code. But what's really exciting about Unity 2017 is we're releasing all of these tools for artists and designers as well, and hence Unity Editor for all creators. And this came out as a part of Unity 2017. And one of my favorite features of Unity 2017 that can also be used for VR, AR, MR development is timeline. And if you've been paying attention to what Unity's been talking about lately, you might have heard a little bit about Timeline before. It's directly integrated into Unity, and it is a sequencer that allows you to sequence animations, activate objects, and you can throw in cameras in there as well. And it's really, really easy to use. You don't have to touch the code, but it's also fully extensible. So if you are a programmer and you want to write custom timeline tracks, you can. A lot of big studios are using it, like Baobab, and actually the 2 other cinematic VR projects that I mentioned up front are using Timeline for their stories. To control a timeline, you just call it from your script. A timeline is actually an asset in Unity, so you create it and you just reference that asset. It's a playable director. And if you want to play your timeline, you just call timeline.play. So for VR, a good example of this would be you're in a VR scene and maybe you walk up to a certain, I don't know, like a counter, and there's someone there, just like any game, like someone there who's going to interact with you. Once you walk through that collider, you could call mytimeline.play, and that would then play back your timeline. And of course, a bunch of other functionality in there as well. Like I mentioned before, you can create custom timeline clips if you want. I think this one, oh, it says right there, this one is for showing subtitles. So if you want to add in some text into your scene, you can do that using the playable extensibility and create those in as custom timeline tracks. If you're more interested in timeline, we have some demos going on at our booth tomorrow at 1 p.m. and Thursday at 11:30. We also have our head of cinematics presenting here in this room at 5 p.m., and he will probably be going over a little bit of timeline as well. Another incredibly friendly tool for artists is our new video component, and that actually came out with Unity 5.6. And this is really great for making 360 video, which is very applicable to VR. And I recognize some of you from, I did this demo earlier at the booth, but I'm just gonna go ahead and do it again for those of you that missed it. Let's jump back into Unity. And I only have one Unity project that I haven't opened yet. All right, so we're starting from scratch. Basically, I have just an empty Unity scene here. So with the new video component, you can create 360 videos in Unity without writing any code. So it's really nice, really great tool for filmmakers and artists. And to do so, you just select what video you want and you drag it into your hierarchy here. So I'm gonna just select this Creek video, and I can view view in the inspector some information about my video here. And right now it's set to just render to the camera far plane. So if I hit play, it'll just take over my screen there, and you can see it's an equirectangular video. That's not really what we want. We want it to be wrapped around us. There's a couple ways we can do this. We can create a sphere, and we can attach the 360 video to the inside of the sphere using a shader that flips the normals of the sphere. But there's also a way that you can create a skybox out of a video. And we actually just released 5 days ago a custom shader that allows you to do this, and it looks really nice. So I'll show you all how to do that. So here I have my video, and I'm just viewing it in Inspector here. And instead of having the render mode be camera far plane, I'm going to go ahead and select render texture. And this is going to be the texture that that video is going to render on top of. And now I just need to create a render texture. So I'm going to do that right here. Call it, I already created one earlier, but I spelled texture wrong, so I'll spell texture right this time and build that. And it's kind of tricky to, whoops, trying to do a zoom. There we go. So here's my video texture, render texture. And we obviously want it to be 2D because it's video. And now I need to figure out what size I want it. So I can do that by going back and looking at my video here and checking out the source info. And down here, I can check to see what my size is. So I know it's 3840 by 1920. So I'm just going to add that in here, 3840, 1920. And I want to have my depth buffer be set to no depth buffer. All right, so that's my video texture. If I go back to my video here, which is called Creek Edited, I can just drag that video texture into the target. And now, when I hit play, we're not actually going to see it playing back in Unity yet because we still have to create the skybox. But we will see some frames render. Oh, I need to have that not minimize or maximize. We will see the frames rendering right in here, and they already are. So we know that the video is mapping to the texture. And next I need to make this into a skybox. So to do that, I'm just going to go create material, and I'm going to call this video skybox 2, since I already created one earlier. And this is where that new shader comes in. So under my shader section, I'm going to go to Skybox Panoramic Beta. So I had to import this shader from GitHub. It's not built into Unity yet. It will be later this year. And I'll show you guys all where you can find that shader and start using it right away. And I have a couple of options here. I can map it either latitude, longitude, which is what I'm going to do because I'm using the equirectangular video format. Or I can also do the 6 frames layout, and that's if you're using more of a cube mapped video format. And then I want my image type to be 360 degrees. You can also do 180 degrees if you're just doing a partial, a partial 360 video is 180. Just in front of you. All right, so now that I've created that skybox, I just need to drag my render texture to it, and that's video texture here. All right, so now we can kind of see that it's working down there. And I'm just going to go into my lighting tab, and up here I have my skybox material info, and I'm just going to set that to be my skybox that I just created. And now we can see that it's actually mapped to the skybox in my scene. And if I hit play, oh, I forgot I have my headset plugged in. I can look around, and there's my 360 video, and because we're using this nice new shader, even below my feet is mapped really nicely, and up above. And a really great thing about using Unity for 360 video is that you can do real-time rendering with it. So you can add all sorts of interaction. You can add particle effects. You can add CGI on top of it. In just a few minutes, I created this little demo right here where I just added like a little cabin because it's kind of like in the woods, and a boat over here that's going to float through my scene. And now I have this really nice, like, kind of multi-dimensional world. You see that, okay, the cabin's obviously CG, and that looks like video, or it's just like a really, really good water shader. I don't know. But it totally gives you the illusion that you're here in this forest that you used 360 video to make. So depending on what 360 camera you're using, it could be a cheaper way to create environmental art. All right, so we went over that. And then here's the link to that shader that I just showed. And this actually, I just created a bit.ly out of it, but it'll take you to the public GitHub page for that. And there'll be information on there with the tutorial of how to do what I just did. So if you forgot or missed anything, don't worry. The information is not gone forever. And I will also be talking a little bit more in depth about 360 video at the booth. I already did today, and I will be there tomorrow and Thursday as well. I'll be showing another method to create 360 video and talking about some of the use cases and camera technology and best practices. So if you're interested in that, definitely come by that presentation. Another awesome artist tool that we have is our new post-processing stack. You can do all sorts of crazy post-processing effects into your scene. Most of them apply to VR as well, and we have some demos going on at our booth Wednesday at 1 p.m. and Thursday. Oh, wait, that's not right. That's the same time as these. Oh, no, it's not. It's the opposite. Okay. It's like, did I get this wrong? If any of my times are wrong, I'm pretty sure that that they'll be posted outside of the booth. But I tried to get them right. All right, and another great tool for authoring in VR is Editor VR. And with Editor VR, you can make your VR worlds while in VR. And actually, if you're interested in using this, someone from the Editor VR team, Amir, is speaking right after me, and he will be doing an Editor VR presentation right now. And that's it for my talk here. I hope to see you all at Unite Austin in October. And stay in touch. I'll be around the rest of the week at the Unity booth if you have any questions. I guess we still have 15 minutes. So if anyone has questions now, we can do some questions. Do we have mics? No? Yes? Yeah. Oh, what's the frames per second that the videos can be played? Well, if you're running on Oculus Survive, it needs to be 90 frames per second. Oh, what can we play back? Oh, I actually don't know the answer to that. Check out the, it probably specifies on the video player documentation. And if not, I will find out. The post-processing, we have a demo going on at this time where he can answer any questions about post-processing. Yeah.
Hi.
Anyone else?
Hi, I had a question about the 360
there you are.
Skybox. Sorry.
Yeah.
So one, does that work for version 5.6 or is it just 2017?
Oh, it works in 5.6. You just have to bring the shader in from the GitHub.
Okay.
Yeah, so that link that I showed you, you have to just download the shader.
And one other follow-up. Well, does that also work for reflection mapping, or is there a way to get a reflection map from the Skybox or the 360 Skybox?
I'm not sure if you could actually get the reflection mapping from the video itself. You might have to use just an image for that. That's a good question, though. I can find out and get back to you if you give me your contact info. Yes.
Well, that
Yeah.
was loud.
It's hard to see.
Do you currently support 360 3D video, stereoscopic video?
It's not like built into the editor, but you could do stereoscopic by, instead of rendering the video as a skybox, you could render to the inside of two spheres and have one sphere be the left eye and one sphere be the right eye, just two different videos.
Okay.
Yeah.
Sounds easy.
Right?
With regards to building for, say, HTC Vive and Oculus, that's just turnkey? I mean, what about accounting for differences in controllers? Do you have to do that when you're developing, or is it?
So currently, you do have to do a bit of customization in the input system. We are working on a new input system that will be released with either 2017.2 or 2017.3. I'm not sure on the exact timing, but we are revamping our input system to make it easier to use all of the VR controllers. Right now, you just have to do a bunch of custom mappings for them. All of the info on how to do those mappings, though, is on the Unity scripting reference or the Unity manual. You can find information on how to do that on there.
Is ARKit integration coming, like without using the plugin that you mentioned, at any point?
I actually don't know the answer to that, but the plugin is pretty easy to use, so I would just recommend playing around with that for now. And if native integration is coming, you will definitely hear about it.
Okay, and with the Tango integration that's coming, will that be exposed through like a separate API to the way that the HoloLens stuff gets exposed, or will there be sort of a unified world understanding?
I believe it'll be a
API.
separate API the same way that HoloLens is exposed, yeah.
Thanks.
Hi. When is 2017 supported with the Windows holographic?
That'll be 2017.2.
Yeah.
It's currently in beta, so it'll be fully released later this year.
Not like next month or the next month.
Should be fall.
All right.
Target is fall.
Thank you.
It's hard to state exact release dates, but
And piggybacking on that, I'm not sure how the Windows holographic handles the occlusion that was mentioned, but I'm imagining that the engine outputs an alpha channel or something like that as a solid to address the occlusion.
yeah, so it'll work similarly to how the HoloLens works in that sense.
Yeah, I'm not sure how that works either, though.
Okay,
know?
I'm not sure like the exact way to answer your question, but let's talk after.
All right.
Yeah.
One over this way.
Okay. Hello. So you showed the ARKit on the Apple and like a static 3D object. Can you just does it also work for like high-end gaming? Like if for you were saying about zombies and at a barbecue or whatever, just make that part of a shooter or
Oh yeah,
interactive
totally.
game?
I was just showing how you could just easily drop an object in there. But yeah, you could make a whole game out of it, and just the same way that you would develop like a regular iOS game in Unity, but instead you're using these targets, or you're targeting these planes and anchors to place your objects. So that was just like the most basic level way to get started.
Hi. So forgive me if you address this. I had to run out for a call, but do you guys have any plans to support the kind of Pixvana style? I'll call it foveated rendering, but fovea is in quotes. But basically, rendering only the pixels that the headset is looking at for 360 video, instead of brute forcing like the whole volume. Is that a part of the roadmap or any plans?
Well, ironically, I used to work at Pixvana.
Oh wow.
Yeah. I don't know if that's part of the roadmap,
Okay.
but yeah, can't comment on that.
Okay.
Any other questions? All right, well, if you think of any, I'll be hanging around here for a bit. Thank you guys, and make sure to stick around for the next talk on Editor VR.